Hello everyone, this is Sanjay from CSIT branch. Today my AT Tech Talk topic of the principles of this AI artificial intelligence is the deep learning systems for domain adaptation in computer vision, learning transferable feature representations. So the abstract of this topic is that the main objective of this paper is to focus on deep learning systems for adaptation in computer vision, highlighting the progress, challenges, and future research direction in this field. And the domain adaptation is that domain adaptation algorithms address the challenge of transferring learning across different data distributions, crucial for adapting models to new environments without extensive retraining. Significance: the traditional supervised learning models may fail when test data distributions differ from training data, making domain adaptation essential for practical applications like auto- autonomous driving under weird conditions. So now the deep learning advances are the recent advancement in deep learning have significantly improved domain adaptation, leveraging the deep neural network's ability to learn transferable feature representations. And the knowledge transfer is that the paper discussed different paradigms of knowledge transfer such as multitask learning, self-taught learning, sample selection bias, lifelong machine learning, one-shot learning, zero-shot learning, and domain adaptation. Challenges are the variations in data due to different image qualities, perspectives, background, and modalities cause distribution mismatches, posing a significant challenge for domain adaptation algorithms. The techniques are the piece paper categorizes and surveys various domain adaptation techniques, both shallow and deep learning based approaches, highlighting their strengths and limitations. So the intro is that the traditional machine learning is that the standard machine learning paradigms like supervised learning, training models on labeled data to make predictions on unseen data. This model may not perform well if the tested distribution differs significantly from the training data distribution. The knowledge transfer is that to avoid the need for recollecting labeled data and retraining models from scratch, transferring knowledge between tasks or domains is desirable. Knowledge transfer aims to use information from one domain to improve learning in another domain. Domain adaptation is the domain adaptation algorithms enable models to adapt to new data distributions, addressing distribution mismatches between training and test data. This process is crucial for practical applications where acquiring new labeled data is expensive and time consuming. And the challenges of domain adaptation is that differences in image quality, camera perspectives, backgrounds, and sample diversity contribute to distribution mismatches. And the variations can also arise between different modalities such as RGB images versus sketches or paintings. The examples of distribution mismatches are an autonomous car trained by daytime data may not be performed well at night due to different lighting conditions. A car trained on sunny days may struggle in snow or rain, and a car trained in US may not perform well in London due to different traffic rules and signs. And the importance of domain adaptation is that the domain adaptation reduces training effort when adapting models to new environments, making it crucial for real world applications. It also further transfer of knowledge from one environment to another, enhancing the robustness and applicability of machine learning models. Focus on the paper is that the paper reviews the latest research in domain adaptation using deep neural networks, and it provides us an overview of non-deep learning techniques and organizes that growing body of research in deep learning based domain adaptation. The paper also defines current research drawbacks and suggests future research directions. So the domain adaptation is that the domain adaptation involves transferring knowledge from source domain to target domain to solve a common task, and the challenges faced are the variations in image quality, camera perspectives, backgrounds, and sample diversity can cause distribution mismatches. Training and test data may come from different modalities, what is the depth images, sketches, or paintings. Importance is that essential for applications like autonomous driving, where models trained under certain conditions must perform under different conditions without extensive retraining. And the techniques are, the first technique is the shallow method. It is like the non-deep learning techniques like DSVM, PMT-SVM, and MMDT adapt SVM decision boundaries for project data to common subspace to align source and target domains. And the deep learning involves adversarial networks which generate data to match the target domain, and methods like deep adaptation networks that use maximum mean discrepancy loss to align features. Evaluation is that the domain adaptation algorithms aims to minimize prediction errors on target data, often relying on unsupervised methods where target labels are scarce or unavailable. Adversarial methods are, it utilizes GAN to transform source images into target images, enhancing domain adaptation by ensuring generated images match the target distribution. Generative models is that the cross domain generative models transform images from one domain to another, aiding domain adaptation by providing labeled target like images for training classifiers. Joint distribution alignments is that aligning joint distribution with is more effective than aligning marginal distributions, achieving through iterative label refinement in the target domain. And the person centered models are, future research should focus on developing adaptive models that cater to individual user needs, enhancing technology accessibility, especially for people with disabilities. And the future directions are, address real world applicability by creating domain adaptation models tailored to specific types of domain shifts, and also develop a new data sets based on domain shift models to improve generalization across different platforms. The deep learning domain adaptation survey. So in this survey it is known that the traditional machine learning models often fail when the test data distribution differ from the training data. So the domain adaptation algorithm aims to transfer knowledge from a source domain to a target domain, and by reducing the need for extensive retraining. So the knowledge transfer is that the transfer learning paradigm includes multitasking learning, self-taught learning, sample selection bias, lifelong machine learning, zero-shot learning, and domain adaptation. The domain adaptation is a specific case of transferring learning focused on adapting models to new data distributions. Challenges in domain adaptation is that distribution mismatches arise from differences in image quality, camera perspectives, backgrounds, and sample diversity. The variations can also occur between different modalities such as RGB images versus sketches or paintings. And the shallow domain adaptation methods are, the early techniques relied on handicraft features like shift hog, using linear and non-linear methods to align sources and target domains. Methods such as DASVM, PMT, SVM, MMDT adapted SVM decision boundaries or projected data to common subspace. Deep learning for domain adaptation is that deep learning approaches have revolutionized domain adaptation by learning highly adaptive task specific feature representations. The techniques includes naive hierarchical methods and adversarial learning methods that adopt shallow adaptation techniques with deep networks. Adversarial learning methods are the such as GANs are used for image translation and domain adaptation. modeling source domain distributions to improve target domain performance. Examples include Kogan and variational autoencoder based networks which convert target domain images to source domain images for efficient classification. So I can conclude that the current AI systems excel is narrow tasks like playing chess or Go. Despite progress in AI research through deep neural network, achieving artificial intelligence remains exclusive. The role of transfer learning is like including domain adaptation is crucial for advancing AI systems. And the effective transfer of learning and knowledge augmentation is needed for future AI development. The dominance of deep learning is that the majority of current domain adaptation models are based on deep learning. Before deep learning, domain adaptation relied on fixed data representation. The success of deep learning is that the deep learning adaptability to extract domain aligned features specific to adaptation tasks has led it to success in domain adaptation. This capability has spurred a surge in domain adaptation research using deep learning. These are some of my references. Thank you.